At precisely 9:34 a.m. on April 18th, 1943, Major John William Mitchell of the United States Army Air Force's 339th Fighter Squadron watched through the morning haze over Bougainville Island as two dark shapes materialized exactly where his calculations had predicted they would be. After flying 435 miles across the Solomon Islands in complete radio silence, 18 Lockheed P-38 Lightning fighters had arrived at their intercept point exactly 1 minute early. The twin-boom silhouettes of the American fighters contrasted sharply against the tropical sky as Mitchell's voice crackled through the formation. Bogeys, 11 o'clock, low in the lead Japanese Mitsubishi G4M Betty bomber. Admiral Isoroku Yamamoto, architect of the Pearl Harbor attack and commander-in-chief of the combined fleet, had less than 60 seconds to live. The mission that morning represented far more than a single assassination attempt. Operation Vengeance, as it came to be known, showcased the revolutionary capabilities of America's most unconventional fighter aircraft. The Lockheed P-38 Lightning stood alone among the world's combat aircraft in 1943 as the only twin-engine, single-seat fighter capable of flying over 800 miles round-trip while maintaining the performance necessary for air-to-air combat. No other fighter in the American, British, German, Italian, or Japanese arsenals possessed the combination of range, speed, firepower, and altitude performance that made this impossible mission achievable. But the Lightning's path to that moment over Bougainville had begun 6 years earlier in the offices of the Lockheed Aircraft Corporation in Burbank, California, where two young engineers named Clarence Kelly Johnson and Hal Hibbard were sketching radical designs that would challenge every conventional wisdom about fighter aircraft construction. Their creation would earn grudging respect from German Luftwaffe aces, operational use by Italian test pilots, and a Japanese nickname that translated to two planes, one pilot. Most significantly, it would prove that American industrial innovation could produce aircraft capable of missions that seemed impossible on paper. The story of how a small aircraft company in Southern California created the weapon that killed Japan's greatest naval strategist begins with a simple specification document issued by the United States Army Air Corps on February 8, 1937. Circular Proposal X-608 outlined performance requirements that seemed almost fantastical. A twin-engine fighter capable of 360 miles per hour at 20,000 feet, able to climb to that altitude in 6 minutes, and capable of maintaining full power at that height for 1 hour. The aircraft needed to carry heavy armament, possess excellent high-altitude performance, and serve as an interceptor against hostile aircraft. At the Lockheed Aircraft Corporation's modest Burbank facility, Chief Engineer Hal Hibbard assigned the project to his 27-year-old assistant, Clarence Kelly Johnson. The young engineer had already gained recognition for his work on the Lockheed Model 10 Electra transport, but the Army specification presented challenges that would require completely rethinking traditional fighter design. No single engine available in 1937 could provide sufficient power to meet the performance requirements. Johnson's solution was radical. Mount two Allison V-1710 liquid-cooled engines in separate booms connected by a central nacelle containing the pilot and armament. The configuration Johnson sketched on his drafting table that winter bore no resemblance to any production fighter aircraft in the world. Most pursuit planes featured a single engine mounted in the nose, driving a propeller directly in front of the pilot. Johnson's design placed the pilot in a central pod with engines mounted in twin booms extending behind him, each boom terminating in a vertical stabilizer. The unusual layout freed the aircraft's nose for an unprecedented concentration of firepower: 450 caliber M2 Browning machine guns and one 20mm Hispano cannon, all firing along the aircraft's centerline with no synchronization gear required. The twin-boom configuration offered several advantages that would prove crucial in combat. Counter-rotating propellers, the left engine turning clockwise when viewed from behind, the right turning counterclockwise, eliminated the torque effects that plagued single-engine fighters during takeoff and landing. The wide-set landing gear provided exceptional stability on the ground. Most importantly, the separation of critical systems between two engine nacelles meant that battle damage to one side wouldn't necessarily doom the aircraft, a safety factor that would save countless lives in the Pacific theater. But Johnson's innovative design created manufacturing challenges that pushed Lockheed's capabilities to their limits. The aircraft required precision machining of complex structural joints where the center nacelle met the engine booms. Each boom contained not just an Allison V-1710 engine, but also a General Electric B-13 turbo supercharger, engine cooling systems, landing gear, and control mechanisms. The center nacelle housed the pilot, armament, ammunition storage, radio equipment, and the complex control systems needed to manage two engines simultaneously. On January 27, 1939, Lieutenant Benjamin Kelsey of the Army Air Corps lifted the prototype XP-38 off the runway at March Field near Riverside, California, for its maiden flight. The aircraft performed flawlessly during initial testing, demonstrating a level of performance that exceeded even Lockheed's optimistic projections. On February 11th, Kelsey attempted a transcontinental speed record, flying from March Field to Mitchell Field on Long Island in 7 hours and 2 minutes with only 2 refueling stops. The flight averaged over 300 miles per hour, remarkable for any aircraft in 1939, but ended in disaster when Kelsey undershot the runway at Mitchell Field and crashed, destroying the only XP-38 prototype. Despite the loss of their prototype, the Army Air Corps had seen enough to place an order for 13 YP-38 service test aircraft on April 27, 1939. These pre-production machines differed significantly from the hand-built prototype, incorporating changes necessary for mass production and lessons learned from the crash investigation. The YP-38s featured more powerful Allison V1710-27/29 engines producing 1,150 horsepower each, compared to the prototype's 960 horsepower engines. More significantly, the production aircraft switched to outward rotating propellers, which improved ground handling characteristics but would later create challenges with engine cooling and control. The first YP-38 didn't fly until September 17, 1940, more than a year behind schedule. Lockheed's inexperience with military contracts and the complexities of scaling up production had created delays that would plague the Lightning program throughout its development. The company was simultaneously expanding from a small civilian aircraft manufacturer to a major defense contractor, taking on contracts for Hudson bombers, Ventura patrol aircraft, and the revolutionary Constellation airliner for Trans World Airlines. By the time Japan attacked Pearl Harbor on December 7, 1941, Lockheed had delivered only 69 P-38 Lightnings to the Army Air Forces. Production was finally accelerating, but numerous technical problems remained unsolved. Early P-38s suffered from inadequate cockpit heating, making high-altitude flights unbearably cold for pilots. The complex engine management systems required extensive training, and many pilots struggled with the procedures needed to safely transition from cruise power to combat power. Most seriously, the aircraft exhibited dangerous characteristics during high-speed dives, with controls becoming ineffective as airflow over the tail surfaces approached the speed of sound. Despite these challenges, the Lightning's first combat sorties proved the validity of Johnson's radical design. On August 9, 1942, 2 P-38E fighters of the 11th Air Force's 343rd Fighter Group intercepted a pair of Japanese Kawanishi H-6K flying boats during a patrol over the Aleutian Islands. Lieutenants Stanley Long and Kenneth Ambrose destroyed both aircraft, marking the first Japanese planes shot down by P-38s and demonstrating the Lightning's effectiveness in the challenging conditions of Alaska's weather and vast distances. 5 days later, on August 14th, the Lightning scored its first victory against the German Luftwaffe. Second Lieutenant Elza Shahan of the 27th Fighter Squadron, operating from Iceland, intercepted a Focke-Wulf FW-200 Condor maritime patrol aircraft over the Atlantic Ocean. Working in coordination with Second Lieutenant Joseph Schaefer flying a P-40 Warhawk, Shahan delivered the killing blow that sent the German bomber into the ocean. This engagement marked the first Luftwaffe aircraft destroyed by the United States Army Air Forces, establishing the P-38's place in history as America's first successful interceptor. But it was in the Pacific theater that the Lightning would find its greatest success and face its most challenging mission. The vast distances of the Pacific Ocean, combined with the performance characteristics of Japanese aircraft, created an operational environment perfectly suited to the P-38's strengths. Unlike the close-quarters dogfighting that characterized air combat over Europe, Pacific operations required aircraft capable of long-range escort duties, high-altitude interception, and extended patrols over water where engine reliability could mean the difference between life and death. The aircraft that would carry out Operation Vengeance against Admiral Yamamoto had evolved considerably from those early production models. The P-38 P-38G variant that equipped the 339th Fighter Squadron featured improved Allison V1710-51/55 engines producing 1,325 horsepower each, upgraded turbochargers for better high-altitude performance, and structural reinforcements that allowed the aircraft to carry up to 4,000 pounds of external ordnance. Most importantly for the Yamamoto mission, the P-38G could be equipped with external fuel tanks that extended its range to over 1,000 miles. The men who would fly this mission had been training with their aircraft for months, learning the complex procedures required to safely operate the Lightning's twin-engine power plant. Major John Mitchell, the mission commander, had developed a reputation as one of the most skilled navigation pilots in the Southwest Pacific. His ability to fly precise headings using only compass, airspeed, and timing would prove crucial for a mission that required arriving at a specific point in the vast Pacific Ocean within a narrow time window. The intelligence that made Operation Vengeance possible came from one of the war's most closely guarded secrets: the United States Navy's ability to intercept and decrypt Japanese naval communications. On April 14, 1943, multiple radio intercept stations copied a Japanese message encoded in the JN-25D cipher system. Navy cryptographers at Pearl Harbor's Fleet Radio Unit Pacific, including future Supreme Court Justice John Paul Stevens, worked through the night to decode the transmission. The decrypted message contained detailed information about Admiral Yamamoto's planned inspection tour of Japanese bases in the Solomon Islands. The itinerary specified departure times, arrival schedules, aircraft types, and even the number of escort fighters. Most crucially, it revealed that Yamamoto would fly from Rabaul to Balali Airfield on Bougainville Island on the morning of April 18, following a precise schedule that would bring his aircraft within range of American fighters based at Henderson Field on Guadalcanal. The decision to attempt the interception required approval at the highest levels of the American command structure. Admiral Chester Nimitz, Commander-in-Chief of the Pacific Fleet, received the decoded message from his intelligence officer, Commander Edwin Layton. Recognizing the strategic implications, Nimitz immediately contacted Secretary of the Navy Frank Knox, who brought the information to President Franklin Roosevelt. The president's response, according to historical accounts, was succinct: "Get Yamamoto." But killing the architect of Pearl Harbor would require solving an unprecedented tactical problem. The intercept point calculated by Navy intelligence lay 435 miles from Henderson Field, well beyond the combat radius of any carrier-based fighter aircraft. Navy and Marine Corps F-4F Wildcat and F-4U Corsair fighters lacked the fuel capacity for such a mission. Only the Army Air Forces possessed aircraft with sufficient range. The P-38 Lightning equipped with external drop tanks. Admiral William "Bull" Halsey, commander of South Pacific Forces, tasked Admiral Mark Mitcher with planning the strike. Mitcher selected Major Mitchell's 339th Fighter Squadron because of their experience with long-range navigation and their proven combat record against Japanese aircraft. The mission would require 18 P-38s, 4 designated as the killer flight, to attack Yamamoto's bombers, with the remaining 14 providing top cover against the expected Japanese fighter escort. The complexity of the mission extended far beyond simply flying to the intercept point. Mitchell's navigation calculations had to account for wind drift, fuel consumption, and the curvature of the Earth over a 600-mile roundabout route designed to avoid Japanese radar stations and observation posts. The formation would fly at 50 feet above the ocean to remain below radar coverage, maintaining complete radio silence while navigating by dead reckoning across featureless waters. The P-38s selected for Operation Vengeance underwent special modifications at Henderson Field. Navy personnel installed ship's compasses in several aircraft to improve navigation accuracy. Each Lightning received 2 external fuel tanks, standard 165-gallon tanks under each wing, supplemented by a limited number of larger 330-gallon tanks flown up from New Guinea. The weight imbalance created by mixing tank sizes concerned Mitchell, but tests showed the aircraft could handle the configuration without serious performance degradation. Lieutenant Colonel Luther Moore, a Marine Corps officer, personally supervised the compass installations and navigation preparations. His meticulous attention to detail reflected the mission's importance and its extreme difficulty. Weather reports from coast watchers throughout the Solomon Islands provided wind data that Mitchell incorporated into his flight plan. The final route would take the formation southwest from Guadalcanal, then northwest to approach Bougainville from the ocean side, timing their arrival to coincide with Yamamoto's scheduled departure from Bougainville. At 7:25 a.m. on April 18th, exactly 1 year after Lieutenant Colonel Jimmy Doolittle's raid on Japan, 16 P-38 Lightnings lifted off from Henderson Field's Coral Runway. 2 aircraft had aborted with mechanical problems, reducing the force to 14 fighters plus 2 spares. The formation climbed to cruising altitude and turned southwest, beginning the longest fighter interception mission in military history. Major Mitchell led the formation in his P-38G, tail number unknown but carrying the distinctive markings of the 339th Fighter Squadron. Behind him flew the 4 pilots selected for the killer flight: Captain Thomas Lanfear Jr., First Lieutenant Rex Barber, First Lieutenant James McClanahan, and First Lieutenant Joe Moore. The remaining aircraft formed a loose combat spread, ready to climb to 18,000 feet when they reached the intercept point to engage the expected Japanese fighter escort. For 2 hours and 5 minutes, the formation flew in complete radio silence across the empty Pacific. Pilots fought boredom and discomfort in their cramped cockpits while scanning the horizon for signs of Japanese activity. The tropical sun made the P-38's greenhouse canopy oppressively hot, forcing many pilots to strip to shorts and undershirts despite flying at high altitude. Navigation required constant attention to compass headings, airspeed indicators, and timing, with no landmarks visible except occasional coral atolls. The psychological pressure on Mitchell was enormous. His calculations had to be perfect. A few degrees error in heading or a miscalculation of wind drift could cause the formation to miss the intercept entirely. The success of the mission, and possibly the course of the war, depended on his ability to navigate across hundreds of miles of ocean using only basic instruments and arrive at a specific point within a narrow time window. At 9:33 a.m., exactly 1 minute ahead of schedule, First Lieutenant Douglas Canning called out over the radio, "Bogeys, 11 o'clock, low through the morning haze." The P-38 pilots could see 2 Japanese Betty bombers flying in formation with 6 Mitsubishi A6M0 fighters as escort. Admiral Yamamoto was aboard the lead bomber, accompanied by his medical officer, Chief of Staff Admiral Mato Magaki, and several other senior officers. The formation was 15 minutes away from landing at Bougainville Airfield. The American fighters jettisoned their external fuel tanks and pushed their throttles to maximum power, climbing toward the Japanese formation. The Zeros immediately dropped their own tanks and dove to intercept, setting up the engagement that would change the course of the Pacific War. Captain Lanfear and Lieutenant Barber peeled off from the killer flight to attack the bombers while the remaining P-38s climbed to engage the fighter escort. What happened in the next 60 seconds has been the subject of decades of controversy and investigation. Both Lanfear and Barber claimed to have shot down Yamamoto's bomber, leading to a bitter dispute over credit that would persist long after the war ended. Recent analysis of Japanese records, American combat reports, and witness testimony has conclusively determined that First Lieutenant Rex Barber fired the shots that brought down the Admiral's aircraft. Barber's P-38 dove on the lead Betty bomber, opening fire with all 5 nose-mounted weapons at close range. His 50 caliber machine gun bullets and 20mm cannon shells raked the bomber from right engine to tail, setting the aircraft on fire and causing it to crash into the jungle of Bougainville. The second Betty, carrying Admiral Agaki and other staff officers, was also shot down, crashing into the ocean. Agaki survived the crash and lived to command kamikaze operations later in the war, but Yamamoto died in the jungle, still strapped in his seat and clutching his ceremonial sword. The engagement cost the Americans 1 P-38 when First Lieutenant Raymond Hine was shot down by the Japanese fighter escort. The remaining Lightnings successfully disengaged and returned to Henderson Field, where Captain Lanfear's radio transmission announced their success. "That son of a bitch will not be dictating any peace terms in the White House." The mission had achieved its objective, but at a cost that extended beyond the single aircraft lost. The death of Admiral Yamamoto sent shockwaves through the Japanese command structure. He had been Japan's most capable naval strategist, the man who planned the Pearl Harbor attack and conceived the strategy that gave Japan 6 months of victories across the Pacific. His replacement, Admiral Manichi Koga, lacked Yamamoto's strategic vision and aggressive leadership style. The psychological impact on Japanese forces was severe. Their most successful commander had been killed by American fighters in broad daylight, demonstrating the declining effectiveness of Japanese air defenses. But Operation Vengeance represented more than a successful assassination. The mission showcased capabilities that only the P-38 Lightning possessed among American fighter aircraft. No other fighter could have flown over 800 miles round-trip while maintaining the performance necessary for air combat. The Lightning's twin-engine reliability provided the safety margin essential for extended over-water flights. Its heavy armament delivered the concentrated firepower needed to bring down a large bomber quickly. Most importantly, its speed and altitude performance allowed the P-38s to engage on favorable terms and escape before Japanese reinforcements could arrive. The success over Bougainville validated design decisions that Clarence Kelly Johnson had made 6 years earlier in Lockheed's Burbank offices. The twin-boom configuration that seemed so unconventional in 1937 had proven ideally suited to the demands of Pacific warfare. The nose-mounted armament that required such complex engineering delivered devastating concentrated firepower. The twin-engine layout that complicated production provided the reliability essential for long-range missions over hostile territory. Understanding the Lightning's success requires examining the industrial system that produced it. The Lockheed Aircraft Corporation's Burbank facility had undergone massive expansion since Kelly Johnson first sketched his radical fighter design. The company's Plant B-1 complex, where P-38s rolled off the assembly line, had grown from a small civilian aircraft shop to a major defense production center employing thousands of workers. By 1944, 22 subcontractors manufactured Lightning components that were shipped to Burbank for final assembly. The production process reflected both American industrial capabilities and the Lightning's design complexity. Each aircraft began as separate components manufactured throughout Southern California's growing aerospace industry. Engine booms started as aluminum frameworks produced in specialized jigs, with workers installing Allison V1710 engines, General Electric turbochargers, landing gear mechanisms, and control systems. The center nacelle required precision machining to accommodate the pilot, armament, ammunition storage, radio equipment, and the complex control systems needed to manage twin engines. Margaret Sullivan, one of hundreds of women workers at the Burbank plant, recalled the precision required for P-38 assembly. Everything had to fit exactly right. You couldn't just force pieces together like on some aircraft. The Lightning was so complex that one small mistake could ground the whole airplane. Her account reflects the challenges of manufacturing an aircraft that pushed contemporary engineering to its limits. The final assembly line at Plant B-1 stretched for several hundred feet under the California sun, with partially completed P-38s moving from station to station as workers installed engines, wings, landing gear, and armament. The nose section of each aircraft received special attention, as the concentration of 4 machine guns and 1 cannon required precise alignment to ensure the weapons fired where the pilot aimed. Armament specialists spent hours adjusting each gun mount, testing the mechanical systems that loaded ammunition and synchronized firing. Quality control inspectors examined every component before installation. Howard Jenkins, a former Navy petty officer working as a Lockheed inspector, remembered finding cracked engine mounts that could have caused catastrophic failures in combat. "We weren't just building airplanes. We were building weapons that American boys would take into battle against the best pilots in the world. Every rivet, every weld, every control cable had to be perfect." The 5,000th Lightning built at Burbank received special treatment from the production workers. Painted bright vermilion red and named Yippee, the aircraft carried the signatures of hundreds of factory employees who had contributed to its construction. Test pilot Milo Burcham flew demonstration flights in this aircraft, performing aerobatic routines that dispelled myths about the Lightning's handling characteristics. His displays included slow rolls at treetop level with one propeller feathered, proving that skilled pilots could safely fly the P-38 even with one engine inoperative. The Lightning's complexity created training challenges that extended far beyond typical fighter aircraft. New pilots required extensive instruction in engine management, fuel system operation, and emergency procedures specific to twin-engine aircraft. The transition from cruise power to combat power involved a precise sequence of control inputs. Fuel mixture to auto-rich, propeller RPM to maximum, manifold pressure to combat setting, drop tanks jettisoned, gun heaters activated, and gun sight energized. Any mistake in this sequence could cause engine failure at the worst possible moment. Colonel Harold Rao, commander of the 20th Fighter Group, documented the challenges facing inexperienced P-38 pilots in a report that illuminated the aircraft's operational complexity. Imagine a pilot fresh from flight school with less than 30 hours in type, suddenly bounced by experienced German fighters. He must simultaneously manage throttles, mixture controls, propeller pitch, drop tank release, armament systems, and flight controls while maneuvering aggressively in 3 dimensions. The P-38 requires pilots, not just airplane drivers. These training challenges became apparent during the Lightning's early combat operations in North Africa, where American pilots faced battle-hardened German and Italian aircrews flying aircraft they knew intimately. The 12th Air Force's P-38 squadrons initially suffered heavy losses as inexperienced pilots struggled with the aircraft's complexity while learning combat tactics against skilled opponents. The Mediterranean theater provided the Lightning's most challenging combat environment. Operating from primitive airfields in Algeria and Tunisia, P-38 squadrons faced shortages of spare parts, experienced maintenance personnel, and replacement aircraft. The complex turbocharger systems that gave the Lightning its high-altitude performance proved difficult to maintain under field conditions. Engine failures increased dramatically when sand and dust contaminated oil and fuel systems designed for operation from paved runways. Lieutenant Colonel William Leverett, commanding the 14th Fighter Group's P-38s in North Africa, documented the operational challenges in his unit's war diary. We're learning that the Lightning is a precision instrument that requires precision maintenance. These engines and turbochargers weren't designed to operate from dirt strips in sandstorms. Every mission costs us aircraft to mechanical failures, not just enemy action. German and Italian fighter pilots quickly recognized the Lightning's vulnerabilities when operated by inexperienced crews. The aircraft's size made it easy to spot, while its complex systems created numerous failure points that could be exploited by aggressive attacks. Luftwaffe ace Franz Schiess, who became the leading Lightning killer, with 17 confirmed P-38 victories, developed tactics specifically designed to exploit the American fighters' weaknesses. Schiess recorded his observations of P-38 tactics in combat reports that provide insight into German perspectives on the Lightning. The twin-engine American fighter possesses excellent speed and firepower, but many pilots seem unfamiliar with their aircraft's capabilities. They fly in rigid formations that prevent mutual support, and they often fail to use their speed advantage effectively. When attacked, they frequently attempt to turn fight rather than using their superior performance to extend away and attack from advantageous positions. The assessment from Johannes Steinhoff, commanding Jägerschwader 77 in North Africa, was more respectful. Our old Messerschmitt 109s are perhaps a little faster than the Lightning, but fighting the twin-engine fighter is daunting because its turning radius is much smaller than ours, and it can quickly get on our tail if we make mistakes. The concentrated firepower in the nose makes every burst potentially lethal. These mixed German assessments reflected the Lightning's complex characteristics in combat. Against experienced pilots who understood the aircraft's capabilities, the P-38 could be devastatingly effective. But in the hands of inexperienced crews, the same aircraft became vulnerable to pilots who understood how to exploit its limitations. The learning curve was steep and costly in both aircraft and lives. Franz Stigler, the Luftwaffe ace with 28 confirmed victories, offered perhaps the most balanced German assessment of the Lightning's combat characteristics. When we tried to make tail attacks on the P-38, it would disappear, leaving us with our mouths wide open. The Lightning could turn inside us with ease and could go from level flight to climb almost instantaneously. We learned never to fight the P-38 head-on. Its concentrated armament could destroy our aircraft with a single burst. One cardinal rule we never forgot was to avoid fighting the Lightning in a turning engagement. Italian pilots initially encountered P-38s during the Sicily campaign, where the Lightning's long range allowed American fighters to escort bombers deep into Italian airspace. Maggiore Adriano Visconti, commanding the 310th Fighter Squadron of the Regia Aeronautica, noted the psychological impact of facing twin-engine fighters. The sight of American P-38s approaching our bases created immediate concern among our pilots. These were not the light fighters we had grown accustomed to engaging. The twin-engine configuration suggested heavy armament and long-range capabilities that posed new tactical challenges. The most dramatic Italian encounter with the Lightning occurred on June 12, 1943, when a P-38G force-landed at Capo Terra airfield in Sardinia due to compass failure during a ferry mission between Gibraltar and Malta. The pilot, believing he was landing at a friendly base, shut down his engines and prepared to refuel, only to discover he was surrounded by Italian ground crews. Colonnello Angelo Tondi, the Regia Aeronautica's chief test pilot, was summoned to evaluate the captured aircraft. His detailed examination provided Italian intelligence with comprehensive information about the Lightning's capabilities and construction. Tondi's report noted the sophisticated nature of American production standards. The fit and finish of this aircraft exceeds that of our own fighters. Every component appears precisely manufactured, with tolerances that suggest advanced production techniques. The pilot's controls are logically arranged and clearly marked, indicating design consideration for operational efficiency. More significantly, Tondi was authorized to fly the captured P-38G operationally against American bombers. On August 11, 1943, he took off from Guidonia Airfield to intercept a formation of approximately 50 B-17 flying fortresses returning from a bombing mission against industrial targets in Umbria. Using the Lightning's superior speed and armament, Tondi successfully attacked the bomber formation, shooting down B-17G Bonnie Sue, while 6 crew members parachuted to safety. Italian mechanics quickly discovered the challenges of maintaining the sophisticated American fighter. The turbocharger systems required specialized knowledge and replacement parts unavailable in Italy. Fuel system components designed for high-octane American aviation gasoline suffered corrosion when used with lower-grade Italian fuel. Most critically, the complex electrical systems that controlled engine management and armament required technical expertise that exceeded available Italian capabilities. Despite these challenges, Italian evaluation of the captured Lightning provided valuable intelligence about American production capabilities. Engineer reports noted the extensive use of aluminum alloys, precision machining, and electrical systems that indicated advanced American industrial capacity. These assessments contributed to Italian understanding of the material advantages that American forces would bring to bear as the war progressed. The Lightning's service in Italian hands was brief, ending with Italy's surrender in September 1943. But the aircraft's influence on Italian aviation continued after the war, when Italy acquired 100 P-38L and F-5 reconnaissance variants through an agreement signed in April 1946. These aircraft equipped the 4th Wing and other units of the newly formed Aeronautica Militare, serving in reconnaissance, ground attack, and air superiority roles until 1952. Italian pilots who flew P-38s in post-war service provided insights into the aircraft's operational characteristics from a European perspective. Maggiore Giuseppe Byron, who transitioned from flying Macchi C-202 fighters to P-38LS, noted the dramatic difference in capabilities. The Lightning represented a quantum leap in fighter aircraft technology. The speed, range, and firepower exceeded anything we had experienced in Italian aircraft. However, the complexity required extensive training and careful maintenance to achieve reliable operation. The challenges of operating Lightnings in post-war Italy reflected broader issues with transferring advanced American technology to less developed industrial bases. Italian mechanics struggled with the sophisticated engine management systems, electrical components, and specialized maintenance procedures required for reliable P-38 operation. Accident rates remained high throughout the aircraft's Italian service life, with many losses attributed to pilot error and maintenance failures rather than inherent design problems. Japanese encounters with the Lightning began in the Aleutian Islands, where the aircraft's long-range and twin-engine reliability proved ideally suited to operations in harsh weather conditions over vast distances. The first Japanese aircraft shot down by P-38s were 2 Kawanishi H-6K flying boats destroyed during a patrol over the North Pacific on August 9, 1942. These victories established the Lightning's reputation as an effective interceptor capable of operating in conditions that grounded single-engine fighters. As P-38 operations expanded into the Southwest Pacific, Japanese pilots developed tactical responses to the Lightning's capabilities. The aircraft's speed and climb rate meant that traditional Japanese tactics, tight-turning dogfights at low altitude, played to American advantages rather than Japanese strengths. Zero pilots found that their aircraft's superior maneuverability below 200 miles per hour meant little, when Lightning pilots used energy tactics, making high-speed passes and climbing away before Japanese fighters could respond effectively. Captain Saburo Sakai, Japan's most experienced fighter pilot with 64 confirmed victories, provided detailed assessments of Lightning tactics in his postwar memoirs. The P-38 pilots learned to use their aircraft's strengths rather than fighting to our advantages. They would dive from altitude, make firing passes with their concentrated nose armament, then climb away using their superior speed. We could not catch them in level flight, and their twin engines provided safety for extended missions over water that our single-engine fighters could not match. Japanese technical intelligence efforts focused intensively on captured or crashed Lightning components. Engineers at the Mitsubishi Aircraft Company examined P-38 fragments recovered from crash sites, attempting to understand American production techniques and design solutions. Their reports noted the extensive use of aluminum alloys, precision manufacturing methods, and sophisticated electrical systems that exceeded Japanese industrial capabilities. The nickname Japanese pilots gave the Lightning, 2 planes, 1 pilot, reflected both respect for the aircraft's capabilities and amazement at American willingness to assign such a complex, expensive machine to a single crew member. Japanese fighter aircraft typically featured simple construction, minimal equipment, and basic control systems that could be manufactured quickly and repaired easily under field conditions. The Lightning represented a completely different design philosophy that prioritized performance and pilot effectiveness over production simplicity. Lieutenant Commander Minoru Genda, who planned the Pearl Harbor attack alongside Admiral Yamamoto, later acknowledged the Lightning's role in changing Pacific air combat. The P-38 forced us to reconsider our fighter tactics and aircraft design. Its long range meant that American fighters could escort bombers to targets we had previously considered safe. Its speed and firepower meant that our pilots could no longer rely on superior maneuverability to survive encounters with American fighters. The psychological impact of facing twin-engine fighters affected Japanese pilot morale throughout the Pacific campaign. Single-engine aircraft seemed fragile and limited compared to the substantial American fighters that could absorb battle damage and continue fighting. Japanese pilots reported feeling outgunned when facing Lightning formations, knowing that each P-38 carried far more ammunition and possessed greater firepower than their own aircraft. Technical analysis of the Lightning's performance against Japanese aircraft reveals the effectiveness of American design choices. The P-38's nose-mounted armament created a cone of fire that converged at ranges between 300 and 400 yards, exactly the distance at which experienced pilots typically opened fire. Unlike wing-mounted guns that required complex harmonization and created ammunition dispersion problems, the Lightning's centralized weapons delivered concentrated firepower that could destroy enemy aircraft with brief firing bursts. Richard Bong, America's leading ace with 40 confirmed victories, all achieved in P-38s, developed firing techniques that maximized the Lightning's armament advantages. His approach was simple and devastating. Fly directly at the target until within point-blank range, then fire a short burst that concentrated all 5 weapons on a single point. Bong's aggressive tactics resulted in several incidents where he flew through debris from aircraft he had just destroyed, but they also established his reputation as the most effective Lightning pilot in the Pacific. Major Thomas McGuire, the second-ranking American ace with 38 P-38 victories, used different tactics that emphasized the Lightning's speed and climbing ability. McGuire preferred to attack from high altitude, diving on enemy formations at maximum speed, then climbing away for repeated attacks. His methods were more conservative than Bong's but equally effective, demonstrating the Lightning's versatility in accommodating different pilot preferences and tactical situations. The Lightning's effectiveness in the Pacific theater stemmed from characteristics that perfectly matched operational requirements. The aircraft's range allowed escort missions that kept bombers protected throughout their flight profiles. Twin-engine reliability provided safety margins essential for overwater operations where engine failure meant certain death. High-altitude performance enabled operations above most Japanese fighters, while heavy armament delivered the firepower needed to quickly dispatch lightly built enemy aircraft. These advantages came at a cost in complexity that required extensive pilot training and sophisticated maintenance support. Lightning squadrons consumed spare parts and specialized equipment at rates far exceeding single-engine fighters. The aircraft's electrical systems required battery power that was often unavailable at forward airstrips. Turbocharger maintenance demanded skills and tools that many Pacific airbases lacked. Despite these challenges, P-38 squadrons achieved remarkable success rates in Pacific operations. The Lightning was credited with destroying more Japanese aircraft than any other American Army Air Force's fighter type. 7 of the top 10 American aces in the Pacific theater flew P-38s, accumulating victory totals that exceeded the combined scores of entire Japanese fighter squadrons. The Lightning's reconnaissance variants proved equally valuable in Pacific operations. F-4 and F-5 models equipped with cameras instead of armament provided Allied intelligence with detailed photographic coverage of Japanese installations throughout the Pacific. These aircraft flew alone at high altitude, using speed and altitude to avoid interception while gathering information essential for planning bombing raids and amphibious assaults. Major Karl Polifka, commanding the 8th Photographic Reconnaissance Squadron, described the unique challenges of flying single-seat reconnaissance missions in unarmed Lightnings. You're completely alone over enemy territory with no weapons and no fighter escort. Your only protection is altitude, speed, and surprise. The P-38's performance margins made missions possible that would have been suicide in any other aircraft. The Lightning's photographic missions provided intelligence that shaped Allied strategy throughout the Pacific campaign. F-5 aircraft photographed Japanese naval bases, revealing ship movements and construction activities that influenced American operational planning. Airfield reconnaissance identified the types and numbers of Japanese aircraft available for defense against Allied attacks. Most importantly, Lightning reconnaissance flights provided the detailed mapping information needed for amphibious assaults against heavily defended islands. As the war progressed into 1944, the Lightning faced new challenges from improved Japanese fighter aircraft. The Kawanishi N-1K, J. Shirden, and Mitsubishi J-2M Raiden possessed performance that more closely matched the P-38's capabilities, reducing the American fighters' advantages. However, by this point in the war, Japanese pilot training had deteriorated while American aircrew experience continued to improve, maintaining the Lightning's combat effectiveness despite facing better enemy aircraft. The introduction of the P-38L model in mid-1944 represented the pinnacle of Lightning development. These aircraft featured more powerful Allison V-1710-111/113 engines producing 1,425 horsepower each at military power, or 1,600 horsepower using war emergency power settings. Improved cooling systems reduced overheating problems that had plagued earlier models, while enhanced electrical systems provided more reliable operation of complex subsystems. Production modifications implemented during 1944 reflected lessons learned from 3 years of combat operations. Cockpit heating systems finally provided adequate warmth for high-altitude missions. Improved control boost systems reduced pilot fatigue during extended flights. Most significantly, dive flaps installed on late production aircraft solved the compressibility problems that had caused numerous fatal accidents during high-speed dives. The dive flap modification deserves particular attention because it represented one of the war's most successful solutions to a potentially fatal design flaw. Early P-38s could enter unrecoverable dives when air flowing over the tail surfaces approached the speed of sound, creating shock waves that rendered control surfaces ineffective. Lockheed engineers developed electrically operated flaps mounted beneath the wings that disrupted airflow patterns during high-speed dives, allowing pilots to maintain control even when approaching the aircraft's structural limits. Test pilot Milo Burcham demonstrated the effectiveness of dive flaps in a series of dramatic test flights that pushed P-38s to their absolute performance limits. His reports documented the transformation in aircraft handling characteristics. The dive flaps completely solved the compressibility problem. Pilots can now dive at maximum speed without losing control effectiveness. This modification alone makes the Lightning a completely different aircraft in combat situations requiring aggressive maneuvering. The P-38L model's improved performance came at the cost of increased complexity and weight. The aircraft's empty weight had grown from 11,500 pounds in early models to over 12,700 pounds in the final production version. Maximum takeoff weight approached 21,000 pounds when fully loaded with fuel and ordnance, requiring longer runways and more powerful ground handling equipment. Despite the increased weight, the P-38L achieved the best performance of any Lightning variant. Maximum speed reached 414 miles per hour at 25,000 feet, with a service ceiling exceeding 44,000 feet. Range with external fuel tanks extended beyond 2,300 miles, enabling missions that spanned the entire Pacific theater. Most importantly, the aircraft's reliability had improved dramatically through 3 years of continuous development and field modifications. The Lightning's final combat missions of World War II demonstrated capabilities that had evolved far beyond its original interceptor role. P-38s equipped with radar served as night fighters, hunting Japanese aircraft attempting to attack Allied positions under cover of darkness. Droop snoot variants fitted with bombardier positions led formations of bomb-carrying Lightnings against ground targets, combining precision navigation with heavy firepower. Most dramatically, a few P-38s were modified to carry early air-to-ground rockets, presaging the fighter-bomber role that would dominate post-war military aviation. By August 1945, when Japan surrendered, Lockheed had produced 10,037 Lightning aircraft in 18 major variants. This production total made the P-38 one of the most numerous American fighters of World War II, though still far fewer than the Republic P-47 Thunderbolt or North American P-51 Mustang. The difference reflected the Lightning's complexity and cost. Each P-38 required significantly more materials, labor, and time to manufacture than conventional single-engine fighters. The economic impact of Lightning production extended throughout Southern California's emerging aerospace industry. Lockheed's Burbank facility employed over 18,000 workers at peak production, while 22 subcontractors manufactured components that required precision manufacturing capabilities. The complex supply chain created to support P-38 production established industrial relationships that would define American aerospace manufacturing for decades after the war ended. Workers at the Burbank plant represented a cross-section of American society during World War II. Women comprised approximately 30% of the workforce, taking on roles traditionally filled by men who were serving in combat units. African American workers found opportunities in aircraft manufacturing that had been largely unavailable in peacetime industries. Elderly workers returned from retirement to contribute their skills to wartime production efforts. Dorothy Miller, who worked as a riveter on P-38 wing assemblies, recalled the pride workers felt in producing aircraft for combat. "We knew that every airplane we built would carry American boys into battle against the Germans and Japanese. There was no room for mistakes. A bad rivet or loose wire could mean the difference between a pilot coming home or being shot down. We worked long hours because we understood what was at stake." The technical challenges of Lightning production pushed American manufacturing capabilities to new levels of precision and complexity. Each aircraft required over 15,000 individual parts manufactured to tolerances measured in thousandths of an inch. Engine installations demanded precise alignment to prevent vibration and ensure proper cooling. Electrical systems contained hundreds of components that had to function reliably under extreme conditions of temperature, altitude, and vibration. Quality control procedures developed for P-38 production influenced American manufacturing practices throughout the aerospace industry. Lockheed implemented statistical sampling methods that identified defective components before they could be installed in aircraft. Stress testing procedures subjected structural components to loads exceeding those expected in combat operations. Most importantly, comprehensive documentation systems tracked every component from manufacture to final assembly, enabling rapid identification and correction of problems discovered during flight testing. The Lightning's post-war legacy extended far beyond its combat record. The aircraft's twin-boom configuration influenced civilian aircraft designs, most notably the Cessna 337 Skymaster that entered service in the 1960s. Automotive designers, particularly at Cadillac and Studebaker, incorporated styling elements inspired by the Lightning's distinctive profile. Even Hollywood recognized the aircraft's iconic status, featuring P-38s in numerous war films and using recordings of Lightning engines for science fiction sound effects. More significantly, the Lightning program established engineering and manufacturing practices that shaped American aerospace development throughout the Cold War. The Lockheed Skunk Works, which evolved from Kelly Johnson's P-38 design team, produced the U-2 spy plane, State Route 71 Blackbird, and F-117 stealth fighter using organizational methods pioneered during Lightning development. The emphasis on performance over cost, intensive testing programs, and close cooperation between designers and pilots became hallmarks of American military aircraft development. The Lightning's influence on pilot training persisted long after the aircraft left active service. Twin-engine fighter operations required skills and procedures that influenced Air Force training curricula through the jet age. Engine management techniques, emergency procedures, and crew resource management concepts developed for P-38 pilots provided foundations for training programs that prepared aviators to fly complex, high-performance aircraft. Combat veterans who flew P-38s carried lessons learned in Lightning cockpits into post-war careers throughout American aviation. Richard Bong's aggressive firing techniques influenced gunnery training programs. Thomas McGuire's energy management tactics became standard elements of fighter pilot education. John Mitchell's navigation skills contributed to development of long-range mission planning procedures that enabled strategic air command operations during the Cold War. The Lightning's technical legacy proved equally influential in post-war aircraft development. Turbocharger installations developed for P-38 engines provided experience that supported jet engine development programs. Complex electrical systems pioneered in Lightning design influenced avionics architecture for subsequent military aircraft. Most importantly, the integration of advanced systems into a single airframe established design philosophies that characterized American fighter aircraft throughout the jet age. International assessment of the Lightning's effectiveness varied considerably based on operational context and national perspectives. British evaluation reports noted the aircraft's impressive performance but questioned whether its complexity justified the resources required for production and maintenance. Soviet technical intelligence efforts focused on Lightning construction methods and materials, seeking insights into American industrial capabilities that could be applied to Soviet aircraft development. German post-war analysis acknowledged the Lightning's role in establishing American air superiority over Europe and the Pacific. Luftwaffe veterans recognized that the P-38's long range and heavy armament had forced German defensive tactics to evolve throughout the war. The aircraft's ability to escort bombers deep into German territory had contributed directly to the collapse of German industrial production by 1945. Japanese post-war assessments emphasized the Lightning's psychological impact on their forces. The sight of twin-engine American fighters approaching Japanese positions had represented visible evidence of American industrial superiority that Japanese forces could not match. The aircraft's successful execution of the Yamamoto mission had demonstrated American technical capabilities that exceeded Japanese expectations throughout the war. The most comprehensive post-war analysis of Lightning effectiveness came from American official historians who examined combat records, loss rates, and mission accomplishment statistics across all theaters. Their conclusions emphasized the aircraft's unique combination of capabilities that no other World War II fighter possessed. While the P-38 was not the fastest, most maneuverable, or most heavily armed fighter aircraft, it was the only one that combined long-range, twin-engine reliability, heavy firepower, and high-altitude performance in a single airframe. Statistical analysis revealed the Lightning's impressive combat record despite its operational complexity. P-38s achieved a positive kill ratio against all enemy aircraft types throughout the war. Loss rates per mission compared favorably with single-engine fighters, while mission success rates exceeded those of aircraft with similar capabilities. Most significantly, Lightning pilots reported higher confidence levels during extended over-water flights, reflecting the psychological advantages of twin-engine reliability. The Lightning's reconnaissance missions provided intelligence that shaped Allied strategy throughout World War II. F-4 and F-5 variants flew over 90,000 photographic sorties, producing images that guided bombing target selection, amphibious assault planning, and battle damage assessment. The aircraft's speed and altitude capabilities enabled reconnaissance flights over heavily defended targets that would have been impossible for slower, lower-flying aircraft. Mission planning for Lightning operations required sophisticated calculation methods that influenced military aviation throughout the post-war period. The complex fuel management procedures needed for extended-range flights established planning methods that supported strategic air command bomber operations and air-to-air refueling programs. Navigation techniques developed for Pacific Theater P-38 missions provided foundations for intercontinental flight operations that characterized Cold War military aviation. The Lightning's maintenance requirements created logistical challenges that influenced American military support systems throughout the jet age. The aircraft's complex power plant and systems required specialized tools, trained personnel, and extensive spare parts inventories that exceeded those needed for conventional fighters. These requirements led to development of comprehensive maintenance planning systems that supported increasingly complex military aircraft throughout the Cold War period. Training programs developed for Lightning pilots established educational methods that influenced military aviation for decades. The emphasis on systems knowledge, emergency procedures, and complex aircraft management became standard elements of fighter pilot training. Multiple engine procedures, electrical system operation, and advanced navigation techniques pioneered in P-38 training curricula provided foundations for jet aircraft training programs that followed. The Lightning's combat record against German forces demonstrated the effectiveness of American design approaches that prioritized performance over simplicity. While German aircraft typically featured excellent flying qualities and straightforward maintenance requirements, American designs like the P-38 achieved superior performance through technological complexity that reflected American industrial capabilities. This design philosophy influenced military aircraft development throughout the Cold War as American forces emphasized technological superiority over numerical advantages. Pacific Theater operations revealed the Lightning's effectiveness in long-range fighter missions that anticipated post-war military requirements. The aircraft's ability to fly extended escort missions, conduct independent fighter sweeps, and operate from forward airstrips provided operational capabilities that influenced Air Force doctrine throughout the 1950s and 60s. The Lightning's versatility in multiple roles, fighter, fighter bomber, reconnaissance platform, and night fighter, established requirements for multi-role aircraft that dominated post-war military aviation. The Lightning's influence on civilian aviation proved equally significant, though less visible than its military legacy. Test flying procedures developed for P-38 certification influenced civilian aircraft certification standards throughout the post-war period. Flight testing methods that evaluated complex systems integration became standard practice for civilian aircraft manufacturers dealing with increasingly sophisticated avionics and power plant installations. Commercial aviation benefited from navigation techniques and flight planning methods pioneered during Lightning operations. Long-range flight planning procedures developed for Pacific Theater P-38 missions provided foundations for transoceanic commercial aviation that emerged during the 1950s. Weather avoidance methods, fuel management techniques, and emergency procedures established during wartime Lightning operations influenced civilian aviation safety practices for decades. The Lightning's final assessment must acknowledge both its remarkable achievements and its operational limitations. The aircraft succeeded in roles that no other World War II fighter could have accomplished, particularly long-range escort missions and the precision strike that killed Admiral Yamamoto. However, its complexity created maintenance burdens and training requirements that limited its effectiveness in some operational environments. The P-38's legacy extends beyond statistical measures of combat effectiveness to encompass broader influences on American aerospace development, military doctrine, and technological advancement. The aircraft demonstrated that sophisticated engineering solutions could produce capabilities unavailable through conventional approaches, establishing design philosophies that characterized American military aviation throughout the Cold War period. More fundamentally, the Lightning represented American industrial capabilities at a crucial moment in world history. The aircraft's successful development and production demonstrated that American industry could produce highly complex technical systems in large quantities while maintaining quality standards that exceeded those of potential adversaries. This capability advantage proved decisive not only in World War II but in subsequent conflicts throughout the 20th century. The story that began with Kelly Johnson's unconventional sketches in Lockheed's Burbank offices ultimately encompassed far more than the development of a single aircraft type. The Lightning program established American aerospace industry practices, military aviation doctrines, and technological approaches that influenced global aviation development for decades. The aircraft that killed Admiral Yamamoto over Bougainville Island represented not just tactical success in a single mission, but strategic validation of American industrial and technological approaches that would shape the post-war world. As the last P-38 Lightning rolled off Lockheed's production line in August 1945, workers and engineers could reflect on an achievement that exceeded their most optimistic wartime projections. They had created an aircraft that established American technological leadership in military aviation, demonstrated industrial capabilities that amazed allies and enemies alike, and provided combat capabilities that directly influenced the outcome of World War II. The Lightning's thunderous twin Allison engines had announced American presence in skies around the world, from the frozen Aleutian Islands to the tropical Solomon Islands, from the deserts of North Africa to the industrial centers of Germany. The aircraft that began as Kelly Johnson's radical experiment in twin-engine fighter design had become a symbol of American innovation, industrial might, and military effectiveness that resonated far beyond its immediate combat role. In the end, the P-38 Lightning achieved something more significant than statistical success in aerial combat. It proved that unconventional thinking, supported by advanced engineering and sophisticated manufacturing, could produce capabilities that seemed impossible when first proposed. The aircraft that stunned Japan by killing Admiral Yamamoto had demonstrated American ability to transform innovative ideas into decisive military advantages, establishing precedents that would characterize American aerospace achievements throughout the remainder of the 20th century. The final word belongs to Major Richard Bong, America's leading ace, whose 40 victories in P-38 Lightnings made him the most successful American fighter pilot of World War II. When asked to summarize the Lightning's most important characteristic, Bong's response captured the aircraft's essential nature. It was fast enough to catch anything the enemy flew, powerful enough to destroy anything it caught, and reliable enough to bring you home when the mission was finished. For a fighter pilot, what more could you ask? That simple assessment encapsulates the Lightning's remarkable achievement. In an era when most fighter aircraft excelled in one or two performance areas while accepting compromises elsewhere, the P-38 Lightning combined speed, firepower, range, and reliability in proportions that no other World War II fighter matched. It was this unique combination of capabilities that enabled the mission over Bougainville Island on April 18, 1943, when 18 American fighters flew over 400 miles to kill the architect of Pearl Harbor and demonstrate that American aerospace technology could reach anywhere in the world to strike decisive blows against America's enemies. The thunder of Lightning engines faded from combat skies when World War II ended, but the aircraft's influence on American aviation continues to resonate through every advanced military aircraft that followed. From Kelly Johnson's radical design concepts to the Skunk Works programs that produced the most advanced aircraft of the Cold War, the Lightning's legacy lives on in every American aerospace achievement that prioritizes performance over convention, innovation over tradition, and technological excellence over numerical quantity. The P-38 Lightning flew into history over the jungles of Bougainville Island, carrying with it the hopes and capabilities of a nation at war. It returned victorious, having demonstrated that American ingenuity, industrial might, and military resolve could overcome any challenge when properly focused and supported. That demonstration changed not only the course of World War II, but the trajectory of global aerospace development for generations to come.